Classification of stratigraphic map. As I mentioned before, that the stratigraphic map is the most important tool in the communication between different geological information. And also stratigraphic map, it depends on the stratigraphic units and on the properties of these stratigraphic units, such as geometry, lithological composition, faunal content, biocontent, fluid contents, and any other characters. The classification of stratigraphic maps depend on the different bases on the characters of stratigraphic unit. Class A, which depends on the basis of external geometry of rock bodies. What do you mean by external geometry of rock bodies? Means thickness, elevations, and any other characters of rock body. From this characters, thickness and elevation, we can draw two maps. The first one is Eisenbach map. It depends on the thickness of the stratigraphic unit. The Eisenbach map shows the variation thickness of the stratigraphic unit by contour lines, which is called Eisenbach map, drawn through point of equal thickness. And Eisenbach map requires two horizons of key baits, one at the bottom and the one at the top, because it is represented a thickness of stratigraphic units. So there should be or must be there is a key bait for the bottom and key bait for the top to draw stratigraphic Eisenbach map. And you can see figures 12.3 on page 115, which is show different Eisenbach map of different lithological stratigraphic units. The other type, which is it depends on the attitude of the stratigraphic unit or of the upsurface of the stratigraphic unit, means the elevation, الارتفاع مال الوحدات الطبقية. So the definition of structural contour map show the geometric configuration of the rock surface by contour lines drawn through point of equal elevation. So you can note that the difference between Eisenbach map and structural contour map, the structural contour map on the equal elevation, Eisenbach map in the equal thickness, سمك, or the other one elevation اللي هو الارتفاع. The other type, it depends on the composition of the rock of the body. And the composition of the rock of the body, composition in details, composition of the rock body. There are also we can produce different stratigraphic map. First one, isolated map. What do you mean by isolated map? The thickness of single rock type. The thickness of single rock type. If you have an area, there are a sandstone, there is limestone, there is marl, and outcrop represented by sandstone, limestone, and marl, and you concentrated on the thickness of sandstone and draw only map based on the thickness of sandstone. This is called isolated map. So in the single rock units, isolated map of sandstone, isolated map of limestone. Number two, a relative about single rock type. Relative means percentage map. Percentage map, you can calculate it how sandstone represented as a percentage, and from the lithology of the area. 30% sandstone, 50% limestone, 20% marl, and so on. This is called percentage map. Ratio map, if you make a ratio between sandstone and limestone, or sandstone or marl, نسبة, خرائط النسب. Sandstone is higher, the ratio of sandstone is higher than the limestone, or the ratio of limestone is higher than the sandstone. This is called ratio map. There is another technique which is called the triangular ratio, which is represented the composition of the rock units. You can make as a triangular percentage. At the top of the triangle, for example, sandstone, and the right left of the triangle, marl, and the left right of the triangle is sandstone, and you can calculate the percentage of this, and you draw what is called a triangular composition. It is represented as also one type of the composition or three components maps. Other kind of map, it is depends of the stratigraphic map. It depends on the vertical variation map. What's called vertical variation map. This is depends on the internal geometry and composition, such as internal texture or structure or composition of the selected beds, or for example cross bedding, sandstone sorting. It means there you can draw a map for well sorted sandstone, bad sorted sandstone, mixed sorting sandstone, and so on. This is it's and depends on the vertical variable mass. I mean, at the top there is well sorted sandstone, in the middle bad sorted sandstone, and the lower part well sorted sandstone, and so on. This is called vertical variability maps on the basis of position, thickness, and occurrence of specific characters of the rock. From the isobach map, and from the structural contour map, and from the percentage map, and from the vertical variable map, you can conclude different maps. Paleotectonic maps. You can draw paleotectonic maps for the area. If you study in detail the structural contour map and the isobach map and use both of them, you can produce paleotectonic map. Or you can, on the basis of the ratio of change of the facies, you can produce ratio change maps. How the lithology change from sandstone to the limestone, and so on. Another kind is paleogeological map. Paleogeological map, if you study these structural contour map, facies map, and you can mark the unconformity between different stratigraphic units in the area. You can draw what's called paleogeological map for the Eocene, or paleogeological map for the Miocene. For example, if you are looking for the Miocene, in the lower Miocene there is a Sericagni formation, which is an age lower Miocene. In the middle Miocene there is lower Pharis formation, which is age middle Miocene. In the upper Miocene there is upper Pharis formation, and you can draw the thickness of these different formations, so you can produce paleogeological map. I'm an icon, man. My girl about a 10. I should fuck her in the Benz.